Alright, good morning. We're going to continue to look at quadratic equations. We're going to look at roots and zeros and the concepts of roots and zeros. So, roots and zeros are pretty self-explanatory. If we look at the graph, the roots and the zero are going to be where your graph crosses the x-axis. So if I have an axis, this is my x and that's my y. So, these are the x-intercepts. And if I were to label them, say this is 1, 2, 3, -1, -2, -3, -4, I would say that the roots of this graph are x equals 0.5 and -3. 3.5. Another way of saying the exact same thing is by giving ordered pairs. Now my ordered pairs would be 0.5, 0, and -3.5, 0. Now, one thing that I do want to share is that the ways that we are going to look at finding roots or solutions, so we're going to look at 3 ways to find roots or solutions. And that's abbreviated solutions. The 3 ways that we're going to find them is 1, by factoring, 2, with the quadratic formula, or by graphing. By looking at the graph or actually graphing the equation. So let's go ahead and look at our next example. Now, the next example is simply asking you to state the roots. So it's just asking you to state the roots. Now, again, however you want to state the roots is going to be up to you or the instructions that you're given. So let's say, for instance, I wanted the x-intercepts, the ordered pair, or the zeros. This would be the same thing as roots, or all of these are solutions. So if I number this, 1, 2, 3, 4, -1, -2, -3. So let's look at the one on the left. I get my first x-intercept at -0.5. I get my second x-intercept at 3.5. I get the ordered pair at 0, 5, 0. And the second order pair at 3.5, 0. And then this is all redundant. Roots and zeros are the same thing. So you could basically say 0.5, -half, and 3.5 in a set. Those are all solutions. Next, we're going to talk about finding a discriminant. Now, the discriminant has its own formula. So discriminant is going to stand for D. D equals B squared minus 4AC. Now, this b is squared and that 4ac are multiplied. So the results of my discriminant, when d is a positive, that means I'm going to have 2 roots. Now when d is negative, that means I'm going to have 0 roots, so no roots. And then when d is 0, that means I'm going to have 1 root. Let's go ahead and test this. So with item A, this is in standard form, and I know that A equals 2, B equals 3, and C equals 4. I'm going to use this formula, D equals B squared minus 4AC, to find my discriminant, to tell me how many roots, if any, I'm going to have from my quadratic formula. So now we say that D equals 3 squared minus 4 times 2 times negative 4. We're going to do PEMDAS. So I'm going to say 9 minus negative 4 times 2 is negative 8. Negative 8 times negative 4 is positive 32. So D equals 41, which means that I'm going to have 2 roots. Okay? That's all I'm asking for. Let's look at B. Remember, we're saying that B squared minus 4AC is equal to the discriminant. Okay, that's the formula we're going to use on B and C. And that has a little extra parentheses. So let's indicate what A is. A is 1, B is 4, C is negative 12. And now it's not asking for the roots, it's asking for the number of roots, because we're talking about the discriminant. We're not going to factor this. So it just says discriminant and the number of roots. So now I say that D equals B squared minus 4AC. So that equals 4 squared minus 4 times 1 times negative 12. It takes the sign of what's in front of it. So I get 16 minus negative 4 times 1 is negative 4. Negative 4 times negative 12 is positive 48. My discriminant equals 64. So that means I'm going to have 2 roots, because this is positive. Positive means 2 roots. Let's look at C. I see my A is 4, my B is negative 5, and my C is negative 6. It's easy when it's in correct order. So from the highest term down to the constant, I'm going to say equals negative 5 squared minus 4 times 4 times negative 6 equals 25. Negative 4 times positive 4 is negative 16. Negative 16 times negative 6 is 96. Again, this is positive 121. So that means I'm going to have the number of roots are 2 roots because this is positive. Okay, and now that concludes discriminant and roots and zeros. See you next class.